During World War II, two nuclear weapons, Little Boy and Fat Man, were created and were used on Japan. They both rely on the fundamental equation that Albert Einstein came up with, E equals mc squared. First, we have to look at fusion and fission. Fusion is a collision of two particles, and in this case, deuterium and tritium fuse together before producing helium-2 plus and another neutron. Fission is a splitting of atoms, and in this case, uranium-235 splits into barium-144 and krypton-89, and as well as two neutrons. But let's say you have a bunch of atoms. You really will never know exactly when each atom will decay into hydrogen and barium, etc, etc. But you do know when half of them will decay into these elements. This is called the half-life. Different substances have different half-lives, and it is calculated using the formula T equals ln 2 divided by lambda. So using this formula, we can find out that the half-life of uranium-235 is 703.8 million years. So to speed the decay up, we shoot a neutron at a particle of uranium-235, and this particle of uranium-235 will split into barium and krypton while also releasing two neutrons. These two neutrons will hit other uranium-235 particles, and the particles will also release two neutrons, which will hit four uranium-235 atoms, and this is how we get a chain reaction. However, there is a minimum mass for these chain reactions to be sustained because all the atoms are in random motion, and there is no guarantee that one atom will hit the next atom and the next atom will hit the next atom, causing a chain reaction. And that's why we need a critical mass so that there are enough atoms to continue the chain reaction. These reactions give off alpha, beta, and gamma radiations, which are helium-2 plus atoms, electrons, and electromagnetic wave respectively. These particles have different penetration powers through different materials, with alpha particles being the least penetrative and gamma particles being the most. This is due to the charges and masses of these particles. Finally, a note on the power of these bombs. This reaction is so strong that 1 gram of U-235 can release 30 quadrillion mega electron volts of energy in one reaction, which is equal to 22,500 tons of TNT.